everybody, this is Aaron with Explosions Incorporated. Today I would like to talk about a very serious subject that affects all of us. Color-changing fire tornadoes. Now, whether you're being attacked by an evil witch, wizard, or warlock, or perhaps you're just on another magical quest to rescue an enchanted kingdom from the grips of an ultimate evil, we've all been affected by this phenomenon. And today I would like to talk a little bit about the science of color-changing fire tornadoes. Because after all, knowledge is power, and without power, you'll never defeat the Goblin King.
I saw my baby crying hard as babe could cry.
As you'll undoubtedly recall, my fire tornado is formed with a flammable liquid in a fireproof dish that sits on a turntable surrounded by some wire mesh. When you turn the entire contraption, a column of fire is formed by changing the direction that the air flows to the fire. What I'm going to be doing today is using some different chemicals to change the color of the fire and talking about what happens. The addition of cupric chloride yields one particular flame combination. Now we start out with blue because we're using a methyl alcohol as opposed to an ethyl alcohol. This allows the cupric chloride, which is a form of copper, to reach the point at which it begins to burn. As the cupric chloride starts to burn, we get a bright green flame. Let's repeat the process with strontium chloride instead of cupric chloride. In both cases, we're using a metal salt. These are what are commonly used in fireworks to create these colors. Each metal salt has a distinct color when it is ignited. In the case of strontium chloride, that color is red. So what's behind these color changes, other than, of course, magical powers stemming from a pact made with dark forces? Imagine my fist as the nucleus of an atom of cupric chloride, and this ping pong ball as a ridiculously oversized electron that orbits that nucleus. Hopefully you'll remember from science class that electrons orbit their nuclei at discrete levels. What that means is they're stuck in their orbits unless they absorb energy, let's say from a fire or something like that. So in this case, that electron will orbit in one region until it absorbs enough energy, at which point it will jump to another orbit. But this is not the rest state of that electron. So as soon as possible, it will return to its original orbit. As it does that, it will release the energy it absorbed in the form of a photon. Furthermore, the color of the photon corresponds to the wavelength of the energy being released. In the case of cupric chloride, it's a relatively short wavelength, so it's closer to the blue end of the spectrum. It's that bluish-green color. In the case of strontium chloride, it is red. It is a longer wavelength. It's hypothesis time now. What do you think would happen if we mixed together cupric chloride and strontium chloride and then repeated this experiment? Well, pull out your official Explosions Incorporated answer book, write down your hypothesis. Take a minute to think about it. Please remember, you must write down your answer using a number 2 pencil, a yellow crayon, or a sparkly pen with a unicorn eraser. Do your own work, no cheating. Take your time, I'll wait. You remind me of the babe. What babe? The babe with the power. What power? The power of voodoo. Who do you do? What? Remind me of the babe. Oh, you're done. Cool. Let's move on. Due to the different flash points of the varying chemicals involved in this reaction, we get different colors at different points in the flame column, leading to what is known in scientific circles as the flaming rainbow. I hope you enjoy this little talk about fire tornadoes and color change. Please join me next time when I continue to talk about colors and light amplification by the stimulated emission of radiation. I'm Aaron with Explosions Incorporated. Thanks for watching.
And baby said, dance, magic dance, dance, magic dance. Cause I'm a man of constant science, man of constant
Thanks for watching. Check out our other videos. Follow us on Facebook and Twitter, and you can join the Explosions Incorporated dance party too.